Okay, thank you again for joining today's webinar. My name is Anu Adeboje, and I'm on the marketing team at Sensory, and I'll be moderating today's webinar and speaking. Before we get started, a few housekeeping items. We'll be recording today's webinar, and you'll receive an email in a couple of days telling you how to access the recording. It'll be available on our YouTube channel. During the webinar, you can ask questions using the Q&A button, and at the end, we'll address your questions. So there's a Q&A button in your navigation there. Feel free to submit them throughout the webinar, and at the end, we will answer them. So the agenda for today. So as I go through the agenda, members of our panel and our team will wave so you know who they are. We'll begin with an introduction to Sensory from our CEO, Todd Moser, followed by building embedded voice user interfaces with Voice Hub from Jeff Rogers. And then Brian McGrain will provide an introduction to the SensoryCloud and all its features. Then I'll do a dive into SensoryCloud Speech-to-Text. Jonathan Welch will provide an overview of face biometrics, both embedded and cloud. And then we'll continue with Brian Pelham, and he will provide an introduction and overview of voice biometrics and sound ID, both embedded and cloud. And finally, we'll wrap up with some exciting live demos and Q&A. Without further ado, I'll hand over to Todd.
Thanks, Anu. Hi, I'm Todd Moser, Sensory's president, founder, and CEO. I started Sensory, over 25 years ago to allow people to communicate with products very naturally, the way we communicate with each other using sensory functions. In fact, the company was started as a chip company with an inference engine on a very low-cost chip that was running neural networks. So kind of like what people are doing today. We were a good 25, 27 years ahead of our time. We've been very successful at getting our technologies out into a lot of products. We've shipped in over 3 billion products over the years by hundreds of different companies. In fact, I think one of the marketing taglines to join our webinar today was talking about why did Google and Amazon and all these giant companies, the company in Cupertino's licensed our technology. We've had all these licenses from these giants that are great at AI. And why do they choose Sensory? And the quick answer to that is it's a combination of a few very important things. There's accuracy. We're super accurate. We allow privacy because we can do it on device. We have very, very low resource engines, low power, low heat. We support a whole lot of languages and platforms. And over the last year, we've rolled out really a state-of-the-art cloud solution. So our technologies that we have are really, really good. And we'll show that to you today. Next slide, please. Thanks. So let me talk a little bit about the big picture here about features of voice AI types of solutions. And I'll use one of my favorite products on the market, the Amazon Echo and Alexa, as an example of how these things come together. Sensory has a variety of different solutions where we put domain-specific assistance into devices. But I love the Echo. It was introduced back in, I think, 2014. And it's been one of my favorite products. I have about 5 of them in my house. And when you use it, you start with a wake word. You say Alexa to it. And what that does is it wakes the device up, and then you can do a cloud-based revalidation on Alexa. Amazon does this. In fact, when you see the light go off, but then it doesn't respond, what that usually means is that the product false fired on the wake word, and the cloud decided that the things that you said after that weren't relevant enough, so it didn't go forward. So there's this embedded and cloud working together, and Sensory offers both of that, and we'll show you different solutions on the embedded side and the cloud side, and the hybrid kind of solutions as well. You can add biometrics to the wake word if you'd like, and Amazon does this. For example, if I say hook up to my phone and play my music, it knows who I am by my voice. You know, when I ask it to play the news in the morning, it tells me, I can do that, Todd, and it calls me by name. That way, if my wife uses it or my son uses it, it can address them too, by training on the biometrics of my voice. Now at Sensory, we do voice and we do face biometrics. Natural language is the next component in the stage, because after you've said the wake word and after it's identified you, it needs to figure out the intents and what you want to do and what are you trying to accomplish. What is the task that you're trying to complete? And large vocabulary engines that are typically domain specific accomplish this task. When Amazon first rolled out the Echo, it was very, very good at the music domain. I basically used it for playing music and for setting timers. Those were kind of the most popular purposes for it. And they were very, very good at that. And over time, they've added more and more domains to their stack so it can do more and more different types of things. And then there's speech to text and text to speech output. On the Sensory side of things, we do both the tiniest text to speech engines in the world that are used in like answering machines back in the days when we had answering machines. And then we have cloud-based text to speech that's really state of the art and quality. So a final type of technology that can be deployed in these systems is Sound ID. And Amazon does this with their away mode when it listens for glass breaks. So you can set this away mode, and if it hears a glass break, it can respond to that and notify you. Next slide, please. Let me talk a little bit about Sensory's product line, and I'll go through this very briefly because you're going to get demonstrations and examples of each and every one of these. So we have both the embedded side and we have the cloud side of things. On the embedded side, we brand it with the Truly name, Truly Hands-Free, Truly Secure, and Truly Natural. Truly Hands-Free is a wake word engine that can do multiple wake words in parallel. It can do small command sets. It's highly accurate, super tiny, and very robust to noise. It's a micro footprint that we've put on all sorts of DSPs and microcontrollers, so it really runs everywhere. Truly Natural is the next step up. It's a large vocabulary engine where we can do things like statistical language modeling. We can do domain-specific assistance, and we've developed a variety of NLU technologies that can be very, very tiny or larger for intents and entities, and understanding what a person wants when they speak to it. Then the third embedded product we have is Truly Secure, and that's both face and voice biometrics, and we'll show you some really neat demos of this in the upcoming discussions. On the cloud side of things, we do everything that we do embedded, but we do it on steroids because we have less limited, we have more resources to work with. So we have a very, very state-of-the-art speech-to-text engine and text-to-speech engine. We can do all these sort of technologies with higher accuracy and super fast response times. And we'll give you some examples of our cloud and walk you through what the cloud is in the upcoming demonstrations and talks. But up next is Jeff Rogers. He's going to use one of our tools. It's called Voice Hub, and that will allow you to see examples of all of our embedded technologies.
Great. Thanks, Todd. Morning, everybody, or afternoon, evening to all. So Voice Hub, let's see, I think there's a slide anew. If you could put up the slide first, and then I'll jump right into the tool itself. And if not, I can just jump right into the tool. So Voice Hub, we created Voice Hub as a tool for allowing companies and developers to very quickly, thanks Anu, create projects and proof of concepts. And in the past, and with other solutions, if you want to create a custom wake word, well, there's development time and cost, and a command set takes that, and a natural language grammar takes a lot of development time and cost, and data. You'll hear data all the time. And so over the years, because we've been in business for so many years, we've collected a lot of different data. And so we came up with this proprietary approach to synthetic data. And data is really important, obviously, because that's how you build a model, and that's how you balance between a false accept where I'm talking and it says, oh, I think I just heard the wake word, and a false reject where I say the wake word and nothing happens. And so using the synthetic data approach, we can now allow developers and companies to create custom wake words, and you can create 1 to 10 different wake words that are always on, always listening. Custom phrase spotted command sets. So this is a command set that's, again, phrase spotted. So even though there's noise before it and after it with either speech or just background noise, whatever, it still does a very good job of spotting that. And so it has a very natural language feel to it. And then our truly natural engine, which is our large vocabulary engine. And all this can be done for free using our Voice Hub. So you just go onto our website, go to resources, and you'll see Voice Hub, and you can just request access. And it's absolutely free. So let me pop out of this then and do a screen share here, and I'll show you what Voice Hub looks like, and I'll do a couple quick demos here. Okay. So on the left side of my screen is my phone, and I'm just screen sharing my phone. This is an Android phone. We also support iOS in this tool. And then on the right side, you can see the Voice Hub tool. So to start with, I can start with a new project. You can see I can select a custom wake word or wake words. Simple commands. These are both truly hands-free, or truly natural. This is our large vocabulary engine. So I could just select a custom wake word as an example, and then go in here and build it out. So the first thing I can do is I can name it whatever I want. I select my language, and you can see that there's a lot of different languages already included in Voice Hub, from a lot of different Englishes to other European languages and Asian languages as well. And we continue to add languages to this. And you'll note that, for example, we've got English adults. We also have English kids. So if you're doing products where kids are going to speak to it, we have a different model for kids, as we have a different model for UK English and Indian English, Australian English, as an example. I'll just stick with US English. Then the initial size. This is the size of the model that you're going to be building. Now, in a wake word, the larger the model size, the better, of course. But depending on what platform you're running on, you might need a much smaller size. It also depends on the use case. So Todd was talking about the Amazon Echo as an example. That's the typical use case there is distance. But if I'm doing a TWS product or a wearable, well, then I've got a much closer signal, or much better signal to noise ratio. And so I can do a much smaller model. So you can pick here, you can see between 80 kbytes up to about a megabyte. Then you choose the output format. So this is the default is just a Sensory standard SDK, truly hands-free, truly natural. But many of our close chip partners are also listed in here, as well as IP cores. So you could develop for the ARM Cortex M4, or we also have the M7 supported in here. Cadence, as far as the hi-fis go, or chip specifically like Ambic or Cirrus or ST or Qualcomm. You can see a lot of different chip partners that are listed here. And so when you choose one of those, whatever you create in Voice Hub will automatically be formatted for that platform. So then you go down to the wake word and you just type in whatever wake word you want. So I can just type in sensory as an example. And then I hit enter. You see the little speaker icon here. If I press that, you'll hear a TTS engine that plays back what the recognizer is expecting. So it has kind of a little bit of a debug built right into the tool, which is handy. Now, creating a single wake word will typically take about 45 to 60 minutes, depends on how busy the Voice Hub servers are at the time. And the reason for that is that we're balancing out between false accept and false rejects with tons and tons and tons of this data that we have that I mentioned. So let me jump to a project that I already created, since we don't have an hour to wait for the wake word. And this is one that uses truly hands-free and phrase spotted commands. So in my house, I've got a GE dishwasher. And on the front, you've got these little buttons and this tiny, tiny little text that without my reading glasses on, I can no longer read. And I thought, this is a perfect example of where I'd love to add a voice user interface. So I name my project, I choose my language. I've already created a custom Hey GE wake word here. I choose the size that I want. So you can see I'm doing a 147 kbyte size. I'll just use our standard output here. And then I type in the commands. So these are the commands that are on the front of my dishwasher. So nothing special about these. And I kind of wondered about Sandy rinse, wondering how that would work. And again, pressing the speaker, I can hear that, yeah, this is correct. So once it's all done, I build it. And once it's built, I can either test directly on the PC or Mac, or I can download and test it on my mobile phone. So that's the one I like to do here. So this pops up a QR code that I can scan. Now you'll notice that the size is 1.2 megabytes. And that's probably because that GE wake word I did was probably 1 megabyte. and the other model you saw was very small. So the whole thing could be smaller or larger. Again, it's totally up to you. So then on my phone, I scan the QR code here, and you'll see that that scans it right in. And so now I've got my wake word over here. You can see the green line bouncing, so then the microphone's on, and I can just say, hey, GE, I want Pro Wash right now. So even though I said the wake word and I spoke through the whole thing, I said, I want Pro Wash right now, it still spotted that Pro Wash. And so again, with kind of natural language, people might say something like, hey, GE, Express Wash. So even though I said the in kind of before, that doesn't destroy our recognizer. And that's pretty awesome and amazing. So this is all part of Truly Hands-Free. With just a couple more minutes here, let me show you a truly natural project. This is obviously very different because it allows me to construct a natural language grammar. So this is a home automation demo. Todd was talking about how he uses Amazon Echo for different things. Well, you can do the same thing with Sensory, but even better than Amazon, thank you, is we can do a custom wake word, we can do a custom command set, we can do a specific domain that's specific to your product, to your customers and the target market. So here I name it, I choose my language, I'm choosing a size 256 kbyte. That's for the acoustic model size. That's pretty dang small. And you can see there's a lot of different options here. So I've got as far as 80 kbyte up to 8 megabytes. And then if I want a background model, it goes up to 100 megabytes. A background model is basically a huge vocabulary of words that kind of fill in the gaps between things that you might say. I'll use the same output format. I'm using a 200 kbyte Voice Genie wake word here. And then you also have this out of vocabulary rejection setting. So I can be less rejecting or more rejecting. And again, this looks linear, although it's really not. As I change from 20 to 10 as an example, it's a pretty significant change. And I found that 20 usually works pretty well. So then what I do is I come down here and you'll see intents and slots and phrases. Intent is basically what is the thing I want to do? And Todd had talked a little bit about that. So in my demo here, I want to do lighting control, scene control, security control, temperature control, window covering control, whatever. I just made all these up, and just hitting the plus key, I can add more intents. Slots are like a bucket of words or phrases that might be said. And so you can see I've got raise and lower and rooms and scene and all these different things I might say. So as an example, if I go into the room slot, I just added in the different rooms in my house, including some of my kids' rooms here. And if I want to add a sensory room, I can just type in sensory. And you'll notice here that it's page 1 of 1. Well, I could have tens of pages, hundreds of thousands of pages. So it really can be as small or complex as you want to make it. So then the other thing to point out is these predefined slots. These are pretty handy because things like temperature, we've already got temperature for oven setting or thermostat. So in my case here, I just grabbed the thermostat grammar, so I didn't have to write it and create it myself. So under the phrases, what you do is basically drag. It's all drag and drop at this point. I drag my intent down that I want. And then you can see I have like set temperature to, and then I'm using the temperature predefined slot in the rooms. And you'll notice there's a lot of question marks. A question mark means that the preceding word or slot is optional. And so I could say set and I could say temperature, but I don't have to. I could just say 75 degrees in the bedroom, in the master bedroom as an example. Lighting control. So I've got turn on, turn off the bedroom lights or the lights in the bedroom as an example. So again, this allows you to build out and cover all the different variations of things that you think people might say to the product. And then I did the same with security, scene control, and window covering and whatnot. So I come down here and I build it. Now this builds very quickly. This is all phonetic recognizer up here at this point, and I've already got the wake word built. So this will build it. There's a coverage tab which will randomly generate grammars, the things that you could say from the grammar I've created here. But again, I'll go to a quick download here. And you'll see the total size of this, of everything, and there's literally thousands of different things that I could say, is about 600 kilobytes. So then again with my phone. Oh, and by the way, the whole time I was talking, you'll notice there was no mistakes over here. Never thought I accidentally said that wake word or any of these commands. So just really awesome again. So I'll scan the QR code here. So scan that, and that quickly loads into my phone. And on my phone, you can see this auto-generated grammar. There's literally thousands and thousands of different things that could be said. So now with this done, I can say things like, Voice Genie, set temperature to 70 degrees in the family room. So super fast, this is exactly what I said. And you'll also notice that not only do I get the result here, but I get the NLU, or the natural language understanding. So it basically knew it was a temperature control, what was I setting it to, and it was in the family room. Voice Genie, close the master bedroom shades. Voice Genie, select dinner scene. Voice Genie, disarm security system. I created all this in probably 20 or 30 minutes. And you can see it's extremely fast, very accurate. And again, the success of VoiceHub with more than 1,000 developers and companies using today, it really speeds up product development, ideation, and proof of concepts. Now let me turn it over to Brian McGrain, who's going to talk more about our cloud. And if you think these demos are great, wait till you see the demo that he's got to share. Pretty awesome.
Thank you so much, Jeff. I appreciate that. And wonderful demo as always. VoiceHub is a really fantastic product. So hi, everybody. My name is Brian McGrain. I'm the lead cloud architect here at Sensory. And I've had the privilege of taking all of Sensory's amazing technology that they developed over the last 25 years and put it into a cloud product. And so as Todd had mentioned, yes, we offer pretty much everything that our embedded products offer, but on steroids. I would say there are a couple of extra things that the cloud can offer in addition to embedded products. But to give you an idea of the features that we offer specifically, speech-to-text is by far our most compelling product by the fact that we can handle streaming at a higher accuracy than Google and Microsoft, as proven by a third party. We support 17 languages, and it's amazing, but our team is able to crank out a new language almost every week or every 2 weeks. So we're adding more every day. Our face biometrics support single frame passive liveness, which Jonathan Welch is going to talk about a bit later on what that really means, but we are highly resistant to attacks of people trying to impersonate somebody else. And we are glasses invariant. For voice identification, we support active liveness, which basically means that we can ensure that somebody isn't playing a recording to try to act as another individual. And we can handle text dependent and text independent, which basically just means we can authenticate you whether you say a specific phrase or whether you want to say anything. For sound identification, we have custom sound recognition, which is already going to be demoed, and you'll see that. But we support hundreds of sounds in many different domains, and we can even support enrolling custom sounds, maybe doorbells or certain sounds that you guys want to recognize in your applications. And finally, we have text-to-speech across 4 different languages, and we support the creation of custom voices in case you guys want to have your own. Now, SensoryCloud, what's really exciting about this is by having a cloud-based system, there are a lot of advantages. One major advantage, of course, is the horsepower. We have access to GPUs, which means we can use very sophisticated models and very large models to perform all of the features that I showed on the prior slide. But we are also leveraging open source technologies, such as the NVIDIA Triton server, which acts as our inference engine. And what that means is our data scientists, all they have to focus on is creating models in the frameworks that they choose. PyTorch, for instance, is one of them. And so we can take those all of those models and we can drop them right into the NVIDIA Triton server. And that allows us to rapidly release models and iterate on our models. So for instance, if you had a model that was performing well, but you had some improvements or requests, we could create a new model for you. And within 5 minutes, we could deploy that model to your server. So it's extremely easy for us to deploy new models into the field. And the fact that we wrote everything in Go means it's super fast, it's super secure. If your developers are interested in communicating to SensoryCloud, we offer SDKs in 8 different languages, and we can add more at your request, but these are the languages that we support in that first bullet there. We also have a security server that handles OAuth, and I have a security background, and I could probably bore you to tears with that, but just know that we have built SensoryCloud to be secure, to be private, and most importantly, data is not persisted, and all of the inference and all of the processing of images and audio can be done on your servers, and we never see any of it, and we don't want to see any of it, unlike a lot of competitors. Finally, we are fully SOC 2 compliant and pen tested, so you guys can feel very comfortable using this product. So really exciting is I'm actually going to show you this automotive demo that Brian Pelham put together, and he'll be talking in a little bit. But what's really cool about this automotive demo is it takes all the individual pieces of SensoryCloud and combines them together into a singular product, which that's what's really neat about our cloud is we've created these really amazing verticals of technology. And so when you start to combine them and mix and match them, you can make some really incredible things like this. So you'll notice a local wake word detection. You'll notice text-to-speech, speech-to-text, natural language understanding, like Jeff had mentioned. And yeah, it's basically going to act as if you are in a car controlling the navigation system and a few other components. So one thing really important to note is while I have mentioned a lot of things run in a cloud somewhere with some remote GPU, for automotive specifically, we can run our entire cloud on device in the car itself. And I'll talk about this in a slide after, so stay tuned for that.
Voice Genie, turn on my headlights and roll down the front passenger window.
Your low beam are turned on. Opening front passenger window.
Voice Genie, navigate me to 1536 Pine Street, Boulder, Colorado.
Starting navigation to 1536 Pine Street, Boulder, Colorado.
Voice Genie, what's my battery level and what's my range?
The battery level is at 99%. The remaining range is 198 miles.
Voice Genie, send a message to Todd Moser.
Sending message to Todd Moser. What's your message?
Hey Todd, I'm running 15 minutes late. I'll see you soon.
Your message is, hey Todd, I'm running 15 minutes late. I'll see you soon. Do you want me to send it?
Yes.
Message sent.
Voice Genie, navigate me to the nearest charging station.
Starting navigation to the nearest charging station.
Voice Genie, turn on cruise control and set my cruising speed to 70.
Cruise control activated. Cruising speed has been set to 70 miles per hour.
Voice Genie, increase cruising speed by 5 miles per hour.
Cruising speed has been set to 75 miles per hour.
Voice Genie, set the temperature to 72 degrees.
Your vehicle has been set to 72 degrees Fahrenheit.
Voice Genie, play Hotel California by the Eagles.
The song titled Hotel California by the Eagles cannot be played, but a different song can be played instead. Playing smooth jazz music from internet radio.
Voice Genie, set the volume to 7.
Setting volume. The volume has been set to 7.
Voice Genie, stop music.
Radio off.
Awesome. So what's really neat about that demo is everything is actually, all of the major components of that product are running on a Raspberry Pi, a tiny little underpowered, no GPU device. And all the requests are going out to a cloud that's in Oregon, which is about 600-700 miles away from where that demo was located. And you can notice how snappy it was. So our cloud is not only handling all of those requests and all of those different technologies, but it's doing so in a highly efficient, highly performant way. Now, like I mentioned before that demo, we can also deploy SensoryCloud on what we call big embedded. And for instance, one of these pieces of technology is called the NVIDIA Jetson platform, which is kind of like a Raspberry Pi with a GPU, if that's a way to put it, but it's quite small. It's maybe the size of a couple credit cards. And we can actually deploy all of our stack, all of our technologies on the Jetson itself. And we offer smaller models as well for things like the Jetson Nanos. So we can actually get a highly accurate speech-to-text system working on a Jetson in under 30 megabytes, which typically our cloud models are on the order of hundreds of megabytes. So as you can imagine, this is still a pretty small device, and that's why we call it big embedded. So now I'm excited to hand it over to Anu, who is going to be demoing probably my favorite technology in the cloud, and our most powerful, that is a speech-to-text.
Hello, everyone. I'm Anu. Hello again. And as Brian mentioned, and thanks, Brian, for that exciting demo, the SensoryCloud speech-to-text engine is rich with features and capabilities for a variety of applications. Not only is it available in over 16 languages, it's capable of stream batch processing, it's noise robust and highly accurate with fast response times, and is scalable and efficient. Other unique features include the ability to add custom vocabulary for proper names and brand identity, real-time attribution of punctuation and capitalization, and it's highly contextual, meaning it's able to use the context to recognize the difference between words like cite or cite when you say something like, I'm citing this reference or I'm losing sight. So I'll show those features in an upcoming demo, but before we get to that, let's talk a little bit about the performance and the accuracy. As note, early third-party testing using hours of TED Talks demonstrate that the SensoryCloud AI speech-to-text engine achieved best-in-class performance comparable to and exceeding well-known speech-to-text cloud services in normal conditions. The third-party test house used identical test data with no company having access to customized language models, which can affect the results. So that's really just, straight out the bat, early testing, and we're doing really well. And I can tell you and all about it and go on and on about my favorite features, but I think it's best that I just show you in this demo. So sit back and watch.
SensoryCloud has one of the most accurate and lowest latency speech-to-text products in the world. Not only can it handle 17 languages and counting, but it is 100% private, secure, and can be deployed in your cloud. It handles punctuation, capitalization, and a whole bunch of other amazing features that you just won't get anywhere else. Taking a look at the text that was generated, we notice a couple of things. First thing is SensoryCloud was transcribed as SensoryCloud, which is because SensoryCloud itself is a proper noun that our speech-to-text engine doesn't recognize. We can fix that by adding custom vocabulary words. So for instance, we can say, put down SensoryCloud when we hear SensoryCloud or things close to SensoryCloud. And that way our speech-to-text engine knows how to transcribe it correctly. The next thing we're going to notice here is one of our words was highlighted orange. This is because our engine was not entirely sure as to the accuracy of that word, but it printed it out anyways. And so each one of these words, if you notice as I hover over them, has some kind of accuracy number, which indicates our engine's confidence in that word. One last thing you'll notice is the number 17 and the number 100 were transcribed as words. In your application, if you want these to be transcribed as numbers, this is called inverse text normalization. And this is a feature coming in the next couple of months to SensoryCloud. So now that we have our custom vocabulary set, let's give it a second try. SensoryCloud can be tested for free at a demo found at sensorycloud.ai. Go check it out and try for yourself. Thank you very much.
I just love that automatic punctuation and capitalization feature. I don't know about you, but when I dictate text while I'm driving with CarPlay, I'm always embarrassed to see what the text look like later. Just would love to see a feature like that on my iPhone. Now I'm going to hand things over to Jonathan, and he'll tell you all about face biometrics.
Thank you, Anu. So I'm John Welch. I am Director of Vision Technologies here at Sensory, and I'm going to talk to you a little bit about our face authentication and liveness detection products. So face authentication is something that most people are probably familiar with at this stage. Sometimes you hear it called Face ID or facial biometrics. It's a technology where you can take an image of somebody's face and process it in such a way that you get a unique identifier for that individual. Our particular face authentication product has been trained with a number of different types of data that we've collected over the years. We have an application in the Android store that you can go download right now called AppLock. And AppLock is an application that enables you to secure access to individual applications based upon our biometric technology. And what this has enabled us to do is that by distributing this for free, we actually have an opt-in program where you can share your session data. And all of that session data gives us access to a very demographically unbiased set of facial biometric information. And we've accumulated this data from all sorts of international markets, in addition to across a wide variety of different devices. So Whether you're running very low power devices with very low resolution camera sensors, or you're running a state-of-the-art smartphone, we have data as part of our data set that actually helps our models to become very robust across all of those different types of variations. Our system is very robust and it's very strong in the sense that what I've shown here is a very high security threshold. So these two numbers that are shown here, the false reject rate and false accept rate, for those that are not familiar, this is a terminology that corresponds to, in this context, if an imposter is trying to authenticate as somebody that is not them, how often will you see that imposter's biometric actually bypassing the system? That's what we call the false accept rate. So at our highest security threshold, 1 in 500,000 means that if I'm an imposter trying to authenticate as somebody else, it will on average take me 500,000 attempts before I will get one system to get through, or one frame to get through. And typically when you have a false accept rate, then of course you have a paired false reject rate. So that is the opposite, which is if I am the person that I'm trying to authenticate as, how often will the system reject my true biometric? And at this security threshold, we say 5%. And what that really means is that 5 out of every 100 attempts, you may see a false reject. But from a customer user experience perspective, if you're running even as something as slow as 5 frames a second, your users would never notice that you had to collect an additional frame in case you got a false reject. So it's very robust, it's highly secure, and we have a variety of different thresholds that you can authenticate across. For this spatial authentication, we have 2 types of deployments. We have our traditional embedded deployment, in which case everything, including the data and the authentication system, are all on device. So if you're a FIDO compliant application, this is an option that you can add biometrics to your application that way. We also have the in-cloud, which we call it in-cloud, on-prem, or big embedded. So these are all 3 of these use our cloud stack. And in this scenario, you get to use those super thin client SDKs that Brian McGrain mentioned. But you also get to add this additional added benefit, which you don't get currently with the embedded. And that is that if you want to do cross-device enrollment with your biometrics, you can do that with this cloud, meaning that I can enroll on my phone, and then I can go to a workstation or an access panel, anything like that, to be able to actually enroll with the same thing, or I'm sorry, authenticate with the same enrollment that I had before. Additionally, all of our cloud communication is end-to-end encrypted, and so everything is still private in that regard. The next thing that we have is called liveness detection or spoof detection. And so when you have a biometric system, it's really important that you are robust against what are called replay attacks or presentation attacks. And so this is where I may take an image, a photo or a computer screen, something like that, of the person I'm trying to impersonate, and showing that to the biometric system. And very often you'll find that without proper spoof detection, that biometric, that replay attack will get through. And so we have a state-of-the-art approach to doing this liveness detection. And we're very robust against a variety of different attacks, whether they're photos, cutouts, what we call depth attacks. This is trying to give the perception of depth to the camera, or even these hyper-realistic 3D masks, like you see in the lower right corner here. This is something that was created by an artist by hand of our CEO's face. And so we're robust against a variety of different attacks like this. Again, we have 2 deployment modes for this. We've got an on-device, which is a multi-frame, which means it requires more than 1 frame to be able and process the liveness signal. But it's a much lower compute, much lower power model. Or you can use our in-cloud model, which is much more sophisticated, and it actually operates on single frames. So those are kind of the high-level overview of our vision biometric systems. And at this point, I think we'll hand it over to Brian Pelham. Thank you.
All right, thanks, Jonathan. Hi, I'm Brian Pelham. I'm Vice President of Emerging Technologies at Sensory. And so today I want to talk to you about voice biometrics and sound ID. We've been producing voice biometrics for about over a decade now. And as Todd mentioned earlier, they help your product to know your user. There's other use cases for enhanced security or customization, all kinds of varieties of ways. You may be using it to access a bank account. You might be using it to simply know which playlist to play. If I say, hey, Sensory, play my favorite songs. Who said that? We offer 3 biometric types, an enrolled wake word. So if you say the wake word, hey GE, as we saw earlier, you can extend it with biometrics and know who said it. You can also allow your customers to select and define a user-defined passphrase. So if I pick my own passphrase, if I say my favorite football team, Denver Broncos, that could be my passphrase as well. Interesting technologies, we also support text independent mode, where I can enroll my voice by saying a few sentences and then authenticate, or it can identify me by anything I say. And Jeff will show you a live demo of that at the end of this webinar. Regardless of which is your use case, whether it be security or customization of your app. We offer a super large degree of flexibility in how you integrate your solution into your products. We have high security modes that really focus in on low imposter accept rates, and we also have low security modes that really dial in low false rejects. So we want to identify the user without much friction. No matter what you pick, it's really up to you to adjust as you suit for your need. And we also support some added interesting options such as active voice liveness. And again, Jeff will show you digit recognition-based voice liveness later in this presentation. Next slide. In terms of accuracy, we are always trying to reduce the false reject rate against the imposter accept rate. When combined together, we often talk about that as the equal error rate. So lower is better for these biometric systems. We also look at things such as false accept rate. So how often in a continuous listening system does it accidentally trigger if it's listening 24/7 all day long? And you probably have experienced false triggers on your TV set or your Alexa product as well. So we do measure that and we report it. In terms of our biometrics, we typically see between 1% and 3% equal error rate, and it depends on the amount of control you have in your product. If you know the wake word and it's a branded wake word such as Hey GE, we saw earlier, we can build you a very customized wake word model that has the lowest equal error rate possible. And as you go out to very unconstrained environments, you give a little bit in performance, but that may lead to very interesting and dynamic applications for your environment. Typically, when we integrate wake words, we do wake word detection and then layer biometrics on top of it. This allows us to constrain the false accepts in our systems. And then we could use the follow-on query. As you saw earlier, Jeff said, Hey GE, Santa wash, or Hey GE, extended wash. That extended wash command could be used to also instantiate a biometric. So combining it all together, think about things as you build your products, things that affect biometrics, environmental and noise, distance of the microphone from the user, enrollment audio quality plays a factor, and the selection of mic in your products. The good news is that Sensory will work with you to build your products to get the best out of voice biometrics. We often tune and optimize for specific products. So we'll look forward to hearing about the products you want to build, and we'll tune and optimize for your need. Now, on the Sound ID side, we've built a really interesting set of technologies that take voice and face applications to the next level, where you're actually sensing the environment and trying to understand what's going on around you. Our solutions today work on device or in our cloud, as you saw, SensoryCloud. We can detect things such as dog barks and baby cries, very discrete sound events. We support 16 different sounds that are highly tuned, highly optimized. We can also enroll sounds. So if you have a particular sound that's very unique to your product, or something that you specifically want to listen to, or a sound that your customer must hear, such as their own unique doorbell, we can do that with Sensory technology. We can also listen continuously and tell you things such as, is my customer listening to music right now? Maybe I shouldn't interrupt them at this point in their interaction. And I'm kind of happy to say later this quarter, we are going to release a new Sound ID system that can classify up to 400 different sounds and listen to the environment and tell you what it's hearing. So I think I'm very excited to see a much more open ID of sounds in the coming months. Our solution's kind of unique. We just to summarize, we have a low power first stage detector that listens for events. It filters over 95% of the events out. And then once we detect an event, we reclassify it using deep learning technologies. We use the best of deep learning in a paired way to get the best out of low power and high accuracy. And again, here's some sounds that we can detect just as an example. And you're going to see more of that from Jeff, who I'm going to pass this over to. And Jeff's going to show you some very interesting live demonstrations.
Great, thanks, Brian. We're a little short on time, so I'll go through these demos quickly, but know that you can access these demos from our site as well. So let me turn off my camera so I can use my camera for the demos. And then if I can just grab the screen here. Okay, so let me show you a couple quick demos in the time that we have left. So this is our biometric demos. And so I'll do a new enrollment just so you can see the whole process here. So I've got face turned on, I've got voice turned on. I typically wear glasses. Yeah, I got that on because I do when I'm looking at my screen. You can see I can change the liveness setting here. I'll just leave that at medium. I can pick the language I want for the voice recognition because this is going to have active liveness with voice, which is super cool. and then I can just type in the name of this demo that I want. So let me do a quick enrollment. So actually, I did that backwards, but that's okay. 874-610. 670-409. 584-500. 172-660. Okay, so now I'm enrolled with both face and voice. So here's my sensory demo that I just did. So if I want to do face only, you'll see as soon as the camera turns on, it's like instant. Face match, liveness detected. And if I use the creepy photo of myself that my daughter loves so much, and I put that in front of the camera, I'm like, oh yeah, this is me, and I'm moving around. I mean, this is a high quality photo as far as printing goes. And you see that it wasn't matched and there was no liveness detected. But with the real me, it's almost instant. I mean, it's really awesome. Then if I want to do face and voice together, I'll combine these together. You'll see how quickly the camera says, yep, that's me. And then I read out the digits and it says, yeah, that's actually me saying the digits. 916166. So I spoke those digits very quickly. It matched my face, it was liveness, and it was active liveness. So if somebody had a recording of me, they obviously couldn't get in. We go down to the voice ID side of things. So this is we talked about text independent verification, anything I say. So this is a sensory demo here. And so as I'm speaking now, it's basically learning my voice. It's building a template of my voice. So really, once I'm using the product, I can literally say anything and it will say that's Jeff. And you could combine this with our speech to text and other technologies, such that I say the wake word, and then I say I want to go here or do this or turn on this or whatnot, and it combines those together and says, okay, not only did I recognize what you said, but I know it was Jeff saying it. So now when I run this demo here, as I start talking, you'll see that it's going to say, yep, that recognized me. And as I keep talking, it'll keep saying I recognize. If I stop for a second, and then I start talking again, you can see right here how quickly from the silence to when I said, and then again, I mean, it's literally within 1 or 2 seconds. So it's really, really fast, very responsive. Let me jump to our sound ID just really quickly here. So sound ID, we've classified different categories as Brian showed. So here's the health one, and you'll notice that I've got cough, sneeze, and snore. So as I turn this on, and if I start coughing, it's going to respond very quickly to that, and I cough twice in there. And you'll notice that we got home sounds. So you can see a bunch of different home sounds, as well as safety sounds, different alarms and whatnot. And this can be used in the car. This can be used in the home. This is all part of our sound ID technology. And then just for the last demo, our speech to text, so I'm going to just turn on a couple quick things here and then say, and to end our demonstrations today, let me just end with this. Thank you for allowing us to spend time together to show you all the different technologies that we can provide. We really, oh, I must have missed this here. Let me start again. And to end our demonstration today, let me just end with this. It doesn't seem like it's doing that for some reason. I'm not sure why. Okay, here, now it's actually listening to me. I'm not sure why it wasn't before, but you can see this is total live. And so whatever I'm saying, it's typing it out. And I turned on the capitalization. I turned on the automatically stop listening after I was done talking. So really cool. You could obviously tell that I wasn't reading that and I was making it up as I go. This is our speech to text. So again, appreciate all the attendance here. A lot of different cool technologies. Turn it back to Anu for the Q&A section.
As all those demos that you saw that Jeff just demonstrated are available at SensoryCloud.ai. And if you want to sign up for any of the other demos, you can head there. I'm going to copy and paste those URLs into the chat so you can see it. And now we'll head into the Q&A. Like I said before, enter your questions into the Q&A and I will read them and then our panelists will answer them live. Okay, so we've got one anonymous question that says, what is the throughput for your STT engine? How many users can one GPU support?
That's a great question. And it's a tough one to answer as well, mainly because it highly depends on your application. If you have a product that is streaming continuously for 24 hours to the GPU, essentially hogging up GPU space, that's a much different problem than, let's say you had like a command and search application where your users would hit a button and they would say, where's the nearest restaurant? That's about 8 seconds of audio versus 24 hours of audio being used by the same user. So it really depends on your users. But for instance, we've had a couple of customers who approached us and they have more of the command and search application requirement in mind. And that can easily support tens of thousands of users on a single GPU across the course of a month. So really, if you're talking about individual GPUs, and that's on a 1080, which is a quite underpowered GPU, but really it depends on your application. So if you're interested in speech to text, you should probably reach out to our sales team and they can figure out with the engineering team exactly how many GPUs you would need for your application. But we are highly competitive in terms of the way that we benchmark against other technologies.
Okay, does adding a voice ID increase or decrease FARs or FRRs? Does the new automotive implementation account for environmental noise?
Yeah, so these are really, really great questions. So actually adding a voice ID to it does decrease the false accept rate. So because it's listening for a specific person's voice, it's not going to go off on other people's voices. It's not going to go off on other environmental sounds. Now, it probably increases the probability slightly that it would go off on your own voice. So there's some question of what the mix is between your own voice and other things. But in general, we believe it decreases the false accept rate and improves the accuracy overall. In terms of automotive implementation and the environmental noise, the SensoryCloud is the most noise robust speech recognizer I've ever experimented with in my life. And I've tried everything out for years and years and years. I can crank up noise in my background and it seems to work well. How it performs in automotive noise, we haven't done any benchmarking at this point, but we'd be happy to work with anybody out there that's interested in trying it.
Great, thanks, Todd. So we've got another question here. It says, how simple is it to have Sound ID or the LV CSR on MCUs like M4 or M33 with large memory, but running a simple RTOS?
Yeah, I can take that one, Anu. I'll start with Sound ID. Sound ID today has been designed to run on an application processor with a standard OS. So right now, today's Sound ID will not run on an M4 and M33. We did a demo where we're running Sound ID on an M7, so that's moving in that direction to answer your question. But today it does require standard Linux or Android or other OS as opposed to an RTOS. LVCSR, Truly Natural can also run on an M7 today. So in the demo that I did with the home control, that I could have done that whole demo running on an M7. So as an example, we partnered very closely with ST, and on ST we're running on their H7, which is based on an M7 today. But today, Truly Natural doesn't run on an M4. We've got a demo where I think it will run on an M33. So these are things that are kind of in development and we're testing right now. Truly hands-free can run across all of those platforms. Truly Natural, some of those, and Sound ID, again, more designed today for running an application processor. Good question.
One thing I'll add to that that's kind of interesting, we've been doing some work to increase our compatibility with TensorFlow Lite. And we have compatibilities with Truly Hands-Free, Truly Natural, and Sound ID with certain TensorFlow models. It depends on which choices you make. So it's possible that if TensorFlow is supported on a sub OS system, on a micro or a DSP, we could also support that.
Okay, and I just want to thank everyone because we're running out of time and and I don't want to keep anyone longer, but I thank you so much for joining this webinar. I know it was packed full of information. I've copied and pasted the relevant links into the chat. And as I noted before, the webinar will be available, recorded and available and sent to you via email. So just want to thank everyone again for joining today. And we hope you have a good rest of your day wherever you are. Thanks a lot.
Thanks all. We appreciate you showing up.